Hello everyone. In last few sessions, we have learned basic principles of counting. Now, before I proceed, let me revise once more the important things about counting principles. And in that, first comes as that let us talk about multiplication principle. Now, how we had done multiplication principle? One example I am taking here, suppose a committee is to be formed where a head and a cashier and a typist is required. A committee of 3 people is expected. Now, if that is the thing, then main task is actually to form the committee, correct? That is formation of the committee. What are the subtasks? To appoint a head, to appoint a cashier, and to appoint a typist, which I'm writing there as capital H, capital C, and capital T. Okay. So, task would be complete only when H is complete, when C is complete, and T is complete, right? So, in multiplication principle, you will have to complete all subtasks. Then only you will be able to find the required number. Means find number of ways to complete each subtask and multiply them. And that would give you finally the number of ways in which that main task can be covered or done. So, multiplication principle comes here, right? And now next could be towards addition principle. A committee is headed by a boy or a girl or a girl. So boy or a girl. Two options are possible. Okay. Task is to form the committee. That means basically to select a boy or a girl. Correct? If I say capital G is number of selections of girl, means possibilities, all possibilities. And if I write capital B as number of selections of boys, and we find that B intersection G is 5, obviously both those two are not connected at all, then I will be going for actually addition principle. Means a boy or a girl selection if I am making, then that task would be complete. And number of B union G, means either a boy is selected or a girl is selected, would be number of B plus number of G. And mind you, please, I am writing here union, so I have actually encircled that or. Or word will tell you that we are going for nothing but union. And this was your actually nothing but the addition principle. So, when a task can be completed in more than one way, then we go for addition principle, right? And one more thing I would say, that when we go for, yes, bijection principle. For that, let me take two sets A and B, and number of counting elements of set A is difficult. Number of elements of set B, that part counting is easy. Then what should we do? But for that, for immediate requirement is that counting number of elements of A and counting number of elements of B, it's one or the same. That means equivalent. If that is known to you, then only we go for actually bijection principle. Bijection principle says that instead of counting number of elements of A, you can always count number of elements of B. Now this was regarding what we have done in the last one. Now from here I proceed towards next, and that is a new term called factorial. We are going for factorial. Factorial word perhaps you must have heard. I don't know how you have used. Let me introduce you here fresh. Now, what is the definition? If I am saying I have to introduce you, I will have to write proper definition. And definition is factorial n, which is denoted as n and then exclamation mark, is the product starting from n up to 1. Means n, then keep decreasing one by one. N into n minus 1 into n minus 2. Continue like this until you reach 3, 2, 1. So that the entire product is named as n factorial. You may be wondering that why am I writing a special name to it? But instead of writing that all big, the entire product, it is better to write it in compact form. So the notation n factorial as n exclamation mark. Now, what type of things we observe about this factorial thing? N factorial and n into n minus 1 factorial. They would be same. Do I need to give you any explanation? I hope you will understand why I am saying so. Correct? So let us take few small examples. If I have to calculate 8 factorial minus 6 factorial, how do we simplify that? Now in 8 factorial somewhere 6 factorial is involved. What is 8 factorial? That is 8 into 7 into 6 factorial. So I can take 6 factorial common, and I have written in next step as 6 factorial into 8 into 7 minus 1. And that would give you 6 factorial into 55. So final answer would be 39600. Now 39600, since I have to complete the problem, so I am writing. But from examination point of view, many times you will find the options written in factorial notation itself, right? So I go for one more example. For example, if you have to solve or simplify 12 factorial upon 9 factorial, how do we do it? Again, in 12 factorial, 9 factorial is involved somewhere. So we write it as 12 into 11 into 10 into 9 factorial, so that 9 factorial from the denominator will get cancelled, and simply you will be left with 12 into 11 into 10, which gives you 1320 as your answer. Now, completing answer up to 1320 was comparatively a child's play. My main emphasis was that you should be able to understand that 12 factorial contains 9 factorial so that you can proceed further. Okay. Now, there are certain important things which you can remember. First of all, you will get somewhere 0 factorial. Now, I'm not getting into the proof of 0 factorial. Why is it 1? But you must remember this as a result. 0 factorial is 1. And suppose you get somewhere 2n whole factorial. Now, how you will simplify that further if required anywhere at some stage? 2n will have even terms also, like 2, 4, 6, 8, etc. You can take 2 common from them, right? 2n terms will have n even terms. So, 2 raised to n can come out. Rest all would be 1 into 2 into 3 up to n type, which gives you n factorial. And the odd terms I have written at one place, that is 1, 3, 5, 7, etc. This particular right hand side expression would be required maybe in some simplification where you have to write straight away what is your 2n factorial. And one more I will write in this series, and that is n factorial would always end in 0 whenever n is greater or equal to 5. What would be the reason? Because somewhere 5 is involved and there is always 2 in it. And that product of 5 and 2 will give you 0. So, n factorial whenever n is greater or equal to 5 will always end in 0. Now, this is about factorial. Let us take few illustrations to get more clarity. Now, my first illustration is 1 upon 9 factorial plus 1 upon 10 factorial equal to x upon 11 factorial, and we have to get value of x, and 4 options are given and we have to pick up obviously the correct option. Now, from where we start? As I said before, somewhere in 10 factorial, 9 factorial is involved. So, if I go for taking LCM, then I can always write this as 1 upon 9 factorial plus 1 upon 10 into 9 factorial equal to x upon. Now, there also that 11 factorial is appearing, which I will write as 11 into 10 into 9 factorial. So, everywhere I have got that 9 factorial, which I will cancel. And simple expression I get as 1 plus 1 by 10 equal to x upon 110. That is easily solved for getting x, and x turns out to be 121. I think this was easy for understanding. Only thing is, how do we write 10 factorial? I'm using property n factorial equal to n into n minus 1 factorial. That I have used here. I hope most of you must have got that. Now I go for next example from here, and next example is that if an is n upon n plus 1 factorial, an is expressed or defined as n upon n plus 1 factorial, then we have to get summation an where n takes values from 1 to 50. And I'm given again some 4 options and we have to pick up the correct answer. Now, first of all, this notation sigma, that summation thing what I have written here, if it is new to you, then please go to topic called sequence and series and you may just revise once, or maybe in 1 or 2 statements I can tell you here as that notation E kind of what you are seeing, that we use for summation, and an is written there. N varies from where to where? 1 to 50 means we are actually wanting to get A1 plus A2 plus A3 up to A50. Whenever you want to write this big series, we use this sigma notation and we write there from where to where that n has to vary, right? So basically what we are looking for here is I have to get answer for A1 plus A2 plus A3 up to A50, which I am writing here as sigma an. Okay. Now this was about sigma, but then how do we actually start the problem? Now an is n upon n plus 1 factorial. Then I write on both sides sigma, like whatever is the required thing. Now the intuitive part is that I can write n as n plus 1 minus 1. Now why do I write that n plus 1 minus 1? Because I have certain steps in my mind. Now you may ask that, but what prompts you to get it as n plus 1 minus 1? One thing I can say intuitively, and secondly, once you start practicing questions, then such ideas would start occurring to you also, not necessarily only to me, right? Okay. So I have written here it as n plus 1 minus 1, and then I split it. I write it as n plus 1 upon n plus 1 factorial minus 1 upon n plus 1 factorial. And that finally leads to 1 upon n factorial minus 1 upon n plus 1 factorial. And now, you start giving values to n, and you will see something like this, that 1 upon 1 factorial minus 1 upon 2 factorial. Next would be 1 upon 2 factorial minus 1 upon 3 factorial, and so on. By writing this, what are we achieving? That 1 upon 2 factorial gets cancelled. At one place it is coming with negative sign, at other place it is coming with positive sign. So that gets cancelled. Same is with 1 upon 3 factorial also, and so on. So only terms left would be first one, that is 1, and the last one, that is minus 1 upon 51 factorial. So final answer would be 51 factorial minus 1 upon 51 factorial. So my correct option would be C. What was the thing which was to be understood here? That how to split, which I have written as n plus 1 minus 1 in the second step. Now, this particular idea you will be using repeatedly in the chapter sequence and series. There you would learn that once you get the practice, that how do we split, then such questions look actually child's play, right? So here I end my session. Next time when we come again something with new. Till then, stay tuned. Thank you. Hope you have liked the video. If you want to subscribe, click on this side. And if you want to place order for the book, click on this side. Thank you.